or something like that. All right, let's get cracking. Let's get straight into it. This is the measurement question that I wanted to do with you on Tuesday. So let's have a look at it tonight. All right, we're dealing with exam type contextual questions for revision of measurement. So here's question 3. It says in the diagram below, it shows a floor plan of a living room of Sokoto's family house. We see a floor plan there, and we also see an arrow. Okay, so this reminds us of a map work question, and what I can see is the arrow going the other way. Usually the arrow is pointing this way. Maybe they're just trying to trick us, but there's an arrow there. Maybe they'll ask us a map work question. Usually this is linked to a map work section. And we've got a rectangular floor plan, and then it says study the information below and answer the questions that follow. The dimensions of the room are given there. I don't know if you notice, we've got 2 dimensions already on our diagram, a breadth and a length. But the third dimension that they mentioned down here, height, we can't see because this top diagram here is a 2-dimensional image looking down from the roof onto the floor. So we can't see the height of the walls, but they are telling us there is a height here. Okay, let's keep that in mind. All right, here's the first question. Calculate the perimeter of the living room in millimeters. Use the formula below. All right, there we go. So there's your first question. Calculate the perimeter of the living room. You can use the perimeter of a rectangle formula. And remember, be careful. They want the perimeter in millimeters. That's very strange, but we're going to give them the units that they want. So off you go. It should take you about 2 minutes to calculate that perimeter. You use the formula, put in your length and breadth. Be careful because your units are in centimeters and meters. So I suggest you change them first. Change them first to millimeters and then put them into your formula. Okay. Give you 2 minutes to do that. All right, I've just had someone give me a message that I'm breaking up. Guys, just let me know if you can hear me clearly or not. Just let me know if the video and the sound is working correctly. Just you guys tell me if you can't hear or see me properly. All right. All right, if you are struggling with the video or the sound, try logging out, then logging back in. It might help. Okay, so do we have any answers yet for the first question, calculating the perimeter of the room? If you do and you finish, just put some answers into the chat, then I can see that you guys are done. And then we can go ahead and do this one. I'm just writing the formula out. All right, no worries. Okay, you guys still keep going. You do have to do some converting first before you go into the formula, so it does take a little bit of time. It's for 3 marks, this question. All right, no worries. You guys go for it. Thanks for letting me know. Thanks for giving me the feedback. You keep going. So we should be back in business. You guys should have an answer in front of you. I've started already. What I've done is I've taken the length and the breadth because the formula needs length and breadth, and I've converted the length and the breadth into millimeters first. Now, this is very, very important, especially if your formula has multiplication in it like it does here, because when you multiply units in a formula, you get square units, and to convert them back into something else, you are going to run into problems. So always convert first before you put it into your formula. All right. So we've converted my length, which was centimeters. Okay. And I said, I want to convert that to millimeters. So I times by 10.
Sorry, sir.
And, yes.
Sorry, sir.
I'm listening.
So you're breaking, sir.
Kia, can you hear me? Is it breaking up? All right, guys. Looks like we're having some technical issues. Thank you for... All right, so some people can hear me loud and clear, and some people are breaking up. What I recommend, those people that are struggling with sound or the screen, try disconnect from the lesson and then reconnect again. Okay, that often fixes the issue. Try doing that. But thank you for the feedback. Looks like we are having technical issues tonight with all the load shedding that's switched on at 6. Okay, so I converted the centimeters by multiplying by 10, and I got millimeters. For meters to get to millimeters, I have to multiply by 1,000. All right, so I got my millimeters that way. Now everything's in millimeters because the question wants millimeters. Now I can sub into my formula. So I'm going to put it all in now. These are big numbers. It's fine. We're doing exactly what they asked. They are big numbers. So if you're concerned, whoa, these numbers are very big, you have a right to be worried. But if you are very, very worried about how big this is going to be, I'll show you now with the answer.
But his times
all right. Then what's going to happen here is we're going to have 2 times multiply, and I'm going to put the numbers in 8,500 times 3,500. Okay, just like that, and we get a massive number. Now, if you see a number this big for an answer, I would be concerned. I would be thinking, whoa, I must have done something wrong. Okay, now you have 2 options. Number 1, you can go over this whole question again step by step on your own. All right, I'm going to write this number out and I'll show you what I would do. So we've got 595 and 1, 2, 3, 4, 5 zeros. 595 and 1, 2, 3, 4, 5 zeros. Oh, and I've made a mistake. This is why this person is probably raising their hand. Yes. I see now. It's way too big. We need to add those bad boys. All right, so let's go back here. My apologies. I see my mistake. Delete. We need to add. That's better. Hold on a second. I'll be with you now. We'll just write this on the 24,000.
Hello, sir.
Yes. How can I help you?
Doing the calculation is not responding.
I'm with you. I can hear you. I'm listening.
So I can't hear, sir.
Yeah, I suggest disconnect and reconnect again. That often fixes the issue. Okay, so try disconnect and then reconnect again. It does sometimes happen, but a disconnect and a reconnect usually fixes the issue. All right. Okay, yes, there we go. Emmanuel, you are absolutely right to think that's inaccurate. Yes. All right. So when you get a value that big, I'll show it to you again on the calculator. It's massive. I'd be worried. Okay. So when I see this, I'm thinking, hold on, this doesn't look right for the perimeter. So you can either go back and check your sum, all right, immediately in the exam. Okay. If you want to do it quickly, you can. Or what you do is you write your answer down and then you put a little mark next to the question. And that's telling you, I've got to come back to this one. I've done it, but it doesn't look right. And then you're going to come back to it when you've gone through all the other questions. Don't sit on this for 3 marks. Don't sit on this for like 4 minutes or more. All right. It's roughly about a mark a minute in the exam. So if you're sitting here for 5, 6, 7 minutes, you're losing time elsewhere in the exam. So rather put a little mark here and move on. And then you go back over your paper if you've got the time and you come back to this when you see, oh, this didn't look really good. Let me go over it again. Ah, that's where the mistake is. And then you can fix it. Okay. All right. Are there any questions about this one, or are we all happy? We can move on to the next one. That's the perimeter of the rectangular floor, the living room floor. All right. Here's the next question. There it is at the bottom left. Now it says calculate the area of the floor in meters squared using the formula below. So they want area and they want it in meters squared. Okay. Oh, excellent. Thank you, Katlejo. So you guys are going to try that one. Give you 2 minutes. Work out the area. Careful. They want this in meters squared. All right. So the question wants it in meters squared. So like I suggested before, I suggest you change all your dimensions that you need, the length and the breadth, into meters first. Okay. All right, there's a tip there from Kia for those guys who can't see the screen. All right. All right, give you guys a couple of minutes and then we're going to try the second question on the area. Calculate the area, but in meters squared. All right, thank you, Kia. While you guys are doing yours, I'm going to quickly convert my units. Don't watch me. You carry on. You do yours. And we'll meet at the end. All right, if you got an answer, then just pop it into chat. Just let me know that you guys are finished. Yes, Sakina, that's correct. 1 meter is 100 centimeters. All right, how are we doing there? All right. Lubabalo, you okay?
Sorry, sir. I can't hear anything, sir.
There's still nothing.
Sir, I can't hear at all.
Okay. Hold on, I'm going to send you a private message. Or Kia, can you help this guy out? See if we can't help him with his sound while I go over this answer. All right, we got an answer there from Katlejo. Luvalo, Kia's going to try and help you out, okay? With this one, Bianca, question 2. Question 1. All right, I'll quickly run through question 1. While we're waiting for the answer for question 2, I'll run through question 1 again. So question 1 says, calculate the perimeter of the living room, but they want it in millimeters. And they give us this formula here. Perimeter is equal to 2 times length plus breadth. All right, so I'll scroll up here quickly for you so that you can see the calculation. There it is. All right, so because they wanted the perimeter in millimeters and they give us the length in centimeters and the breadth in meters, we have to change those units first. So for my 850 centimeters to get millimeters, I times it by 10. For my 3.5 meters to get millimeters, I times by 1,000. And then that gave me these measurements in millimeters. And then I just subbed it straight into my formula and used the calculator to get the answer. All right. Very funny that they asked for millimeters in this question, but that's what they want. That's what we'll give them. Okay. The second question, we're working out area, and they want it in meters squared. So we are converting to get meters. There's only one dimension that's not in meters. That's the 850 centimeters. So to get meters, I'm dividing by 100 here to get my meters because there's 100 centimeters in every meter. So I divide by 100 there, and that gives me 8.5 meters. Now I've got meters in both of my dimensions, and then I can go ahead and substitute that into my formula. So that's what I'm going to do now. There's my formula, length times breadth. So I'm going to take my length, 8.5 meters, and I'm writing my units. Always show your units so you know what you are doing. All right, and then I'm going to get my calculator. Wake up calculator, there we go, 8.5 times 3.5. Oh, not 6.5, 3.5. There we go. 29.75. 29.75 meters squared. All right, check your answers. Check your answers and see what you guys are getting. We should all be getting the same one. All right, good. Okay. We are now going to move on to volume. All right, so we've done conversions. We did a little bit of length, all right, and we did speed and distance and time. We've done area and we've done perimeter. Now we're going to move on to a volume question. All right, guys, remember, if you have a question about anything that I'm doing on the screen here, please raise your hand and let me know. Okay. All right, here it is. Here's the question. So I'll read it with you. The grade 11 learners of Spola Secondary School are planning to start a vegetable garden. They will use a tank to store water for irrigation. The tank is 2.5 meters long and its diameter is 150 centimeters. So that information is important. All right. The following formulae and the conversion may be used. So they give you everything. All right. There's a volume formula, a surface area formula, and a conversion in case we need it. All right. And here are the questions below. Here's the first one, question 4.1.1. Determine the radius of the water tank. Determine the radius of the water tank. Who would like to tell me how we do that? How do we work out radius, ladies and gents? Sakile. Hold on a second. Sakile,
Hi, sir.
how are you?
I'm good, and you, sir?
I'm good, thank you. What do I do to get the radius?
Well, I said 150 and
Mhm.
times by a half, which gave me 75.
Good job. So we half the 150, which is the diameter, hey?
Yeah.
All right, excellent. Thank you, Sakile. Good job. Thank you very much.
Okay.
All right, so we're going to take the diameter and we're going to halve it. Okay, so here's a the D for diameter, and you can do it like this, or you could say take your D like Sakile did and say multiply by half. It's the same thing. All right, you can choose either one, but we're going to halve the diameter. So whatever the diameter is, and here it is 150 centimeters. We need to divide it by 2, and like Sakile said, you get 75 centimeters. All right. There we go. Well done, Lasedi. Good job. All right. Question 2. Here we go. Calculate the volume of the tank. Calculate the volume of water in liters. Oh, they want it in liters. Ah, look at that. Liters. And you need to be to 2 decimal places. We know we always do 2 decimal places when it's full. So we've got a full tank. What is its volume? In liters. All right. So let's pull out the formula that we're going to use for volume. Right. And let's just talk about this for a second. Pi r squared h. Okay. So like we've spoken about in the measurement before in term 1, this formula needs pi, which is a number that's always given to you. Here you can see on the screen in the question, they give you pi as 3,142. All right. So that'll go into our formula at pi. Then they've got r, which stands for radius. Now we've calculated the radius. Okay. So that radius is going to go in there, and then we're going to square it. The h is the height of the tank. Now this tank's lying on its side. And I love how they've displayed this, because often we are used to tanks being standing straight up like this. Okay. My drawing is very bad tonight. Okay. So often the tanks are standing straight up like this, and then when you are trying to find a height, you would say that this dimension on the side here is height. Okay. And there's a circle at the bottom and a circle at the top, and the radius is from the middle of the base out to the side. Okay, so that is our R. All right, so we are used to seeing the tank like this, but as soon as you turn it on its side, then a lot of students are like, well, what's the height now? Has the height disappeared? Is this the height of the tank now? Up and down? No. All right. The height of the tank standing up is the same as the dimension hasn't changed when it fell over. Okay, so this height here of the tank standing up is the same as this height here of the tank on its side. All right, please remember that. Okay, so whether it's standing up or on its side, that dimension doesn't change. It's still the same dimension. Okay, so just remember that, especially with rectangular prisms and triangular prisms. All right, so we need a height. Do they tell us? Well, they tell us the tank is 2,5 centimeters long. So this is the dimension that they're talking about here. So this height of the tank is this 2,5 meters long. So because it's on its side, they're saying it's long. All right. But in a normal drawing, that's still the height of the tank. Okay, that goes for H in our formula. All right. So work out the volume. Well, you guys can do it. Quickly do it for me, and then we'll compare answers. So you take pi, you put it in, take your radius, which you've got already, put that in and square it, and then put in your length. All right. I'm warning you though, like I've done in the previous question, that when you put things into the formula, all the units need to be the same. All right. What are the units they're giving us? They're giving us a length, which is 2,5 meters, the diameter, which is 150 centimeters, and we need to figure out what our units are going to be when they come out. Now, hold on a sec, guys. You got to think about this a little bit. If we change everything to meters, will that help us? Well, it's going to cause another issue. Not an issue, we're just going to have to do another calculation, because look here, the question says here, we need the answer in liters. Now, the volume formula doesn't give you an answer out in liters. You've got to use this conversion here to change what the volume formula gives you into liters. Now, look at that conversion. Look at the units that are in there. All right? The units for the conversion are centimeters cubed. So I suggest, you don't have to, you can work it out the other way, but I suggest you change all your units to centimeters before you put it into the formula, because we need centimeters in this conversion after. So change everything to centimeters before you put it into the formula. All right. So the 2,5 meters, we'll do it down here on the side, 2,5 meters, change that into centimeters. All right. By multiplying. Take that value. And then you've got centimeters as a radius. You'll have centimeters here now for the length. Put those into your formula. So all centimeters in your formula. And then from there, I'll show you what we do. Okay, so what kind of volume are you guys getting? Oh, Lauren, that's not very nice that you didn't have a teacher for this. Yeah, we've done quite a bit of measurement in term 1 already, in Watobe. So this may be, you may feel like what is going on here, but we've covered a lot of the measurement basics in term 1. What I recommend is try and follow along as much as you can, okay? And then Watobe posts all their previous lessons on the Watobe YouTube site. So if you go to YouTube and type in Watobe, they have a YouTube channel there. You can actually find all the lessons on conversions where we did all the different types of conversions for this kind of measurement question. All right, so I suggest try and follow along. I will go slow. I will go over this question and the answer again, but try and follow along and then go and watch the measurement videos that we did. We did a lot of metric conversions. Okay, and then we practiced some volume questions. But these questions are contextual exam questions, which they're a little bit more challenging because of how they pose them. But we're breaking it down bit by bit, piece by piece. Okay, so like I said for this question here, we need it in liters. Unfortunately, that means we're going to take our volume answer from the formula and convert it to liters with the conversion that they've given us here. But that conversion is working with centimeters cubed. And we've got one question with meters here, the length, and we got one dimension with meters there, and we got one dimension with centimeters here. So we got to decide which one we want to work with, and I'm suggesting work with the centimeters. Don't change to meters for this formula. Work with centimeters because our conversion at the end has got centimeters cubed. So we want to stick with centimeters here. All right, that's what I'm saying for this question. And then you put the dimensions into your formula, get an answer out. It'll be in centimeters cubed. And then we're going to use this conversion on the left-hand side here to get to liters. All right. Okay, so Keita's looking at his volume answer and he's like, yo, sir, this thing is big. Let's have a look. Let's try it out. All right, guys. So I'm going to move this little conversion that we did here. We changed our tank length from meters into centimeters before we put it in. Now we're going to put all the bits and pieces in. So pi comes from the question over there. So it's 3,142 times r squared. All right, now the r is 75 centimeters. We did that in question 1. So I'm going to put 75 centimeters and I'm going to square it. I always use brackets here. Do you know why? Who knows why I always use brackets here? Who can remember? Maybe someone can raise their hand and tell me, why do I use brackets here? Who can remember why I did this? I know there's people here from term 1 that can remember why I suggested using brackets there. It's just something that I do. Do you remember why I did that? All right, I'll tell you why. So I'll tell you why I do it. So if I remove these brackets, then it looks like, I'll move the two slightly closer. If I remove the brackets, it looks like this number here in the middle is 75 square centimeters. Okay, these two things are very different. 75 square centimeters and 75 centimeters squared are two totally different things. All right, so I'm just using the brackets to differentiate between the two. So on the left is area, an area of 75 square centimeters. On the right, I'm taking a length of 75 square centimeters and I'm squaring it. So that's why I use the brackets to differentiate between the two. You don't have to, you guys are probably smart enough not to worry about that, but I've seen it catch pupils out that they leave the brackets out and then they think that that isn't squaring the number, it's squaring the centimeters. Okay, so I want to square the number here. All right, now on the calculator, what does this look like? All right, so on the calculator, we're going to have 3,142 times, and I'm going to use brackets. I like using brackets, nothing wrong with that. All right, you can't shout at me for using brackets. Times, and I need to times by 250 if I remember. Okay. Sure, Sakili, I see what you mean. All right, so we've got a number here. So 441, 418, 437, 418, 437, comma 5. Maybe you guys also got this number and thought, yes, we celebrate brackets. Yes, so, see, now Sakila, what you've got there is your square on the centimeters. All right, so the calculator, I mean, the calculator is not going to do, it's going to square the number, but if I read what you've written there, that is 75 square centimeter blocks, not the number 75 brackets squared on the outside. Okay. So who can tell me what our units are going to be here now? We've got volume and we're working with centimeters. So what units should I write here at the end of my answer? Then we'll have a look at the answer. We'll talk about how big it is. What unit should I write here, ladies and gentlemen? You should all be typing into your screen. It's hard to type powers, but you should be typing into your screen there. What units am I working with, right? Bianca. All right, Bianca, just check your screen there. We're asking you to unmute. Cubed, yes. Cubed. Very good. All right. So it's cubic centimeters for volume. Okay. Now, let's talk about the size of this number and then we'll talk about the units. Okay. First of all, it's very big. And Asakito was like, sir, I think something's wrong. This number is very, very big. I don't blame you. It does look big because when you square things like we've done here, when you apply a square to a number, it makes it very, very, very big. All right. And we're multiplying as well, hey? So we're squaring and multiplying some numbers together. So I'm not surprised our answer is quite big. When you raise things to a power, they do get quite big. Okay, so I would also worry about this. Maybe we can put a star next to it and say, hey, maybe I want to come back and check this one. But I'm not surprised because we are squaring things and multiplying things together. Can we round off the answer? Well, I've got one decimal place here. The only time you round off anything is at the end of the question. Okay, so I'm not going to round it off until we finish the question. We haven't finished the question yet, okay? Because this question says it wants the volume in liters. All right, we've got the volume in centimeters cubed. Now, the volume formula, ladies and gents, that we just use here never gives you liters. It only gives you millimeters cubed, centimeters cubed, meters cubed, kilometers cubed, etc. It never gives you capacity, which is liters and milliliters and stuff like that. So you're going to have to convert the volumetric centimeters cubed into capacity liters. Okay. Good question, but there. Can we round it off is the question. So sometimes rounding off during a question, you don't run into errors at the end of the question because the rounding only chops a little piece off. And then if you don't do much to that, you kind of get close to your answer at the end. But if you chop a little piece off during your question, and then you take that number and maybe you're going to raise it to the power of 2 or multiply it by something big, the little piece that you've chopped off during your question, if you're going to multiply by things and raise to the power of numbers, that little error, that little piece you chopped off could become a big piece later on in the question. So it's best to keep all the decimals as they are until right at the end. Okay, I know what you're thinking. So what if we get a number like, 2.25 and then something like this? Are you telling me I have to leave that or write that whole thing out? You don't have to write the whole thing out, but save decimals. Don't chop them all off to 2. Okay, so if you're during the question, keep a couple there. I usually keep 4 or 5 to be safe. With 4 or 5, you're not going to run into any issues. So you don't have to write all 9 or 10 decimal places, but don't chop it all off, especially if you are going to do something else with that number, like multiply it or square it. Okay, you could run into issues at the end. Okay, right, let's have a look. Let's have a look. We're getting there now. All right. So this is cubic centimeters. We say that the conversion in the question tells us every 1,000 cubic centimeters is 1 liter. So here is our answer with cubic centimeters. We need to convert this to liters. Every 1,000 of these is 1 liter. So I need to divide this by 1,000. I want to know how many 1,000 cubic centimeters I have in this answer. So I'm taking it here and I'm dividing by 1,000 because every 1,000 of these is 1 liter. All right, so where's my calculator? Come do some work for me. Oh, I've lost the formula. Let's write it all again. So 44,18437.5, then divide by 1,000, please. And this is going to give us 4418,437. Now, this is the answer. So we're going to have to round it off. So I'm looking at the 3, which is the second decimal. Will it change? Yes, it will. The 7 behind the 3 will make the 3 a 4. So this is going to be 4418,44. I'm going to write the whole thing out first, and then I'll show you how we change it. So 4418,4375. 4418,4375 liters. We're in liters now because we've converted it with the conversion. And round it off, we look at the second decimal. Will it change? What's the number behind it? It's a 7. It's above 5. Yes, it will change. So it's 4418,44 liters. All right, so that's how many liters this tank can hold. Okay. Are there any questions? Sure. This is a really meaty, like rump steak kind of question. This is not chicken fillets anymore. We're talking about real meaty questions. It's not tuna flakes here. Any questions about this, guys? Raise your hand. Speak now.
Don't ever hold your peace.
Don't ever hold your peace. Speak now. Do you have questions about what we're doing here? Nobody? I assume
Not
by
a
your
single body.
not a single body. All right, thank you, Saki there. Guys, if you're quiet, I assume that you're happy and you understand what's going on and we can move on. All right. Otherwise, please stop me. Somebody stop me in the middle of the question if you have a question. All right.
Katleo says it's confusing.
It is confusing. All right, I'll go over it one more time because there's a lot to deal with here. Okay, so let me explain my thinking and why I did what I did. I think that's the most important thing because we're trying to learn here how to deal with these contextual questions. What are they asking us? What must I do? Okay, so let's read the question one more time before we move on. So question 411 says determine the radius of the water tank. Okay, now with a contextual question like this, I want to tell you guys something. They scaffold the question. What does that mean? You know, they could have said, yeah, they could have gone straight to 412 and say, calculate the volume of this tank. All right, but it's before they did that, they asked you to change the diameter into a radius because you would need to do that anyway if you want to work out the volume. Your volume formula only needs radius, not diameter. So they're actually scaffolding the question. They're breaking up into little pieces for you. And that often happens in a question like this. So 411 is important for us in 412. Determine the radius. We got the radius is 75. There it is up there at the top right. We got that. Okay. Then they say calculate the volume. Now, if they had left off this, if this wasn't here, calculate the volume. In fact, we don't even need to write that. We all know we need 2 decimal places. Calculate the volume when the tank is full. You guys could do that. All right. The only tricky thing about that, if we look at our formula here, all right, I'm going to highlight the formula. Look at it. There's our formula for volume. They give it to you. Don't have to remember it. They give it to you. When you put the numbers into this formula, all the units must be the same. All right. Let's pretend they didn't even ask for units, meters cubed or centimeters cubed, whatever. If you put anything into this formula here, you've got to make sure your units are the same. And they gave us different units in the question. So that adds another level of complexity. So they give us the height or length of 2.5 meters and the diameter, it is 150 centimeters, which we changed to 75 centimeters for radius. So we got meters and centimeters in our dimensions, which is no good. Okay, either we got to work with meters or we got to work with centimeters. We can't have 2 different units in the formula. Okay, but the clue comes in the question. They tell us, calculate the volume of the water in liters. That could have been meters cubed. Then what would you do? Well, then you'd go to your radius, which is centimeters, right? Up here on the right-hand side, the centimeters for the radius. That would have to change to meters before we put it into the formula because we want all meters units in our formula. Okay, but they also could have asked you this. They could have said, we want the volume in centimeters cubed. All right, well, what do I have? I've got one dimension, which is centimeters. I'm good there. But the other one is in meters. I've got to change that one into centimeters. You'd have to do that first before putting it into the formula because you want all the same units in the formula. So that's very important. Have the same units in the formula, okay? Now, they didn't ask us that, unfortunately. They're really trying to make it hard. They said, calculate the volume of water in liters. Now, volume, when you work out volume, don't look at the next question. I know you guys are looking at it. I'm going to delete it. When you look at volume, all right? We covered this in term 1 and capacity. Volume is millimeters cubed, centimeters cubed, meters cubed, and you don't hardly ever see it, but kilometers cubed. All right, it's usually the first 3. Okay, capacity is milliliters, liters, and kiloliters. Those are the units for capacity. All right. Now, these 2 things are very similar. Volume is all about the space in a container. So our tank, what is its volume? How much space is in the tank? All right. That is in millimeters cubed, centimeters cubed, or meters cubed. That's why they give the dimensions with millimeters or centimeters or something like that. All right. You can work out the volume of the tank. How much space does this tank have using these units? But they say, in fact, they're not scientifically correct. They should say the capacity. But anyway, it doesn't matter. They want the volume in this unit here. All right. But our formula, our volume formula, V for volume, only works with these units here. So what do? Well, we need something to change from volume to capacity. And they tell us here that the link between the two is 1,000 centimeters cubed is equal to 1 liter. All right. So the link between the two is given to you in that conversion. All right. But we can't go to the volume formula and spit out these units, liters, milliliters, and kiloliters. We have to work with the top ones. So we work with the top ones. Now, I said we need to work with centimeters in our formula. Why? Because I looked into the conversion between volume and capacity, and I saw centimeters there. So I want to keep my answer for volume in centimeters cubed, and then it's easily changed to a liter using this conversion here. Okay, so there's reasons why we're doing what we're doing. So what we did in this question, we went, there's the formula for volume and highlighted in light blue. All right. And I said, I want all my units in centimeters, please. So we worked out the radius already in centimeters. Then I took the 2.5 meter long dimension and I changed it to centimeters there. Now I've got centimeters in my formula. All right. So there's my centimeters and there's my centimeters. And it's going to give me centimeters cubed. That's what I wanted. I could have worked in meters, but I saw that the conversion had centimeters cubed. So I'm going to stick with centimeters cubed. Then once I've got my centimeters cubed in my answer, I use the conversion they gave us. They said 1,000 centimeters cubed equals 1 liter. I need my answer in liters. So I'm going to use this now. So I look at my centimeters cubed and I say, how many thousands of centimeters cubed do I have here? Well, I divide by 1,000 and I get this final answer over here rounded off to 2 decimal places. Okay. It is complicated. When you look at the whole thing, when you look at an elephant, someone says to you, you know what? Unfortunately, you don't have a choice. You're going to have to eat this whole elephant by yourself. And you look at the whole elephant, you think, I'm never going to be able to do that. It's impossible. But if you start with one bite, and then another bite, and then another bite, and then another bite, and you just keep slowly working at it, you get to the end of the elephant eventually. All right. So how do you eat an elephant? Piece by piece or bite by bite. We're doing this piece by piece as we go. Now, I know what you're thinking, Teacher Dale, when I look at this question, I don't know exactly where to start. I hear you. This is why you have to practice exam questions, because the more you do this, and also with help like with Watobe or past papers and memos or your teacher or a friend or the Watobe bot, Watobe wizard that we spoke to you guys about, you can give it this question and ask it, what do I do? Where do I start? It'll help you as well. All right, so calculate the volume. Have to use the volume formula in liters. Well, I've got meters and centimeters. What do you want me to do? Well, the clue was here in the conversion. You need to get centimeters cubed. So stick to centimeters everywhere. Sub it into your formula. Get your centimeters cubed. Then cut it up to get to your liters. All right. I hope you guys understand that question now. But we're not going to do the surface area question. I'm gonna leave it on the screen here, so you can take a screenshot. All right, and this can be for your homework. Okay, so there's question 413. So if you want to take a screenshot, you can. It says calculate the surface area to the nearest meters cubed. All right, now where's the formula? Here's the formula for surface area. There it is. You need a 2, you need a pi, which they give you. You need an r, which we have. But be careful. Our r is centimeters. On the top right here, our r is centimeters. So that's going to need to change. Why? Because they want meters. So you have to change that one into meters before it goes into your formula. You need an r, which is in centimeters. You're going to change it to meters. Then you need an h. They give you the height. All right, there it is there, 2.5. And guess what? It's in meters already. So you don't need to convert it. So you chuck it all into your formula. And if you've got meters in your formula, you're going to get square meters out. Okay, so that's your homework. Try work out the surface area for that. And next week, Tuesday, when I see you, I'll quickly go over that answer and we check we got the right answer. Okay.